this one's there. I don't know. Stop sharing. Looks good. Okay. I don't know if I told you this, but if ever you're in office hours and you want me to look at your Excel file, okay, open Excel and then share your desktop with me. Don't share Excel with me, because every time you call up a function, I can't see it. So I'll have a hard time helping you. All right. My goodness, what a crowd. All right. All right, in chapter 5, we explore the relationship between NPV and IRR. We should have taken from this that NPV is the superior of the two. However, we did not examine the underlying assumptions of the NPV method. Okay, in chapter 19, we will examine how to re-estimate the WACC when the assumptions are not met. And we'll also learn alternative methods for evaluating investments. You know what, do I? Is that better? Are you following your screens mostly? I don't know if you can do this. Okay. All right. So I have an example. The Ingram Company has the following book values. Book. Okay. So they have, let's just call this thousands for now. They're millions, who cares? 2,000 in assets, and it's funded with half of that is funded with debt, half is funded with equity. Okay. So we need to find what's the Ingram Company's cost of capital. That's what we're going to do. Because if they're going to do an NPV analysis, that would be the right discount rate for an NPV. All right. We have the cost of debt. We could look up their cost of equity. We could estimate. We'll take the corporate marginal tax rate. Okay, and these three are not enough. We also need the stock price and the number of shares. Okay. So we will use the exact same equation you had in your intro course. The WACC is the debt to value ratio times RD, which is the cost of debt, times 1 minus T plus equity to value times RE. Okay, and then of course D is the market value of the debt, E is the market value of the equity, B is the sum of the market values of debt and equity. Okay, the debt value. Can't emphasize this enough. Okay. To find the debt value, take it from the book value balance sheet. Okay, so what we are doing, we are using the book value as an estimate of the market value. We could reprice their debt, interest rates have changed, we could go through and reprice their debt. We're not going to do that. That's not for this class. Now, when you take a fixed income course like 321, you'll be doing that. You'll be repricing debt. Now, that's their issue, not ours. All right? Debt, long-term debt. This is the only number we take from the book value balance sheet. What's a book value balance sheet? That's the published statements, isn't it? Okay, so our assumption here is that the market value and the book value of the debt are equal. You might recall that all values in the WACC equation are based on market values. Okay, the equity value. Is that enough of those? Never take it from the published or book value balance sheet. Never, never, never. Always multiply the number of shares times the price per share. So when I go into that WACC equation, I need an estimate of E. This is what I'll use. They have, which is which here? I'm trying to remember. Okay, they have a $30 stock price and 50 million shares. So we're going to use 1,500 as their market value. Okay, so now you don't need to do this, but I'm just going to restate the debt and equity based on market values. So this is a market value balance sheet. You don't find these, you create these. Okay. So the debt, we have 1,000. We took that right from the book, so that's fine. So what do you see here? We see that 1,000 of the total 2,500 or 40% is debt. 1,500 of the 2,500 is equity. That's 60%, isn't it? Giving me a total market value of the company, debt and equity of 2,500. So where do I get this number from? All right. Well, the assets of a company are not publicly traded. I don't know what they're worth. So what do? I assume that they're worth what the capital is worth that funds them. So this is just an identity. So take whatever you get here and immediately enter it over here. Is that okay? See, these securities are traded, aren't they? So we have good numbers for these, but the assets are not traded. All right. So let's go to the equation now and come up with a cost of capital for the Ingram Company. And we'll take debt to value. So 1,000 of the 2,500 times the cost of debt times 1 minus T plus the market value of equity divided by the debt plus equity value times the cost of equity, 10.6%. And we are seeing that its cost of capital is 7.94%. So what did we use this for? Okay, you might remember revenues minus cost times 1 minus T plus T times depreciation plus your change in, or minus your change in working capital. So those are after-tax cash flows. This is an after-tax cost of capital. All right. Funding for a scale enhancing project. Okay, for this, what did we get there? For 7.94 to be the correct cost of capital for Ingram, they must fund any new investments in these proportions: 40% debt, 60% equity. Let me show you the consequences of this. Okay. Okay, so several reasons we saw in Chapter 5 that the discount rate is the WACC. What are the assumptions such that the WACC is the correct cost of capital? And for the WACC that we calculate in Ingram to be the correct cost of capital, the project's funding must be scale enhancing. I don't know if you see those words in your book or not, but maybe in different words they're there. Okay, so let's say that Ingram is evaluating a $100 million project. Okay, so what will happen to the left side? Well, you always fund projects on their book value, right? I purchased something based on its book value. And my hope is, of course, that it's worth more than that to the company, but you purchase it based on its acquisition cost as the book value. So Ingram is going to add 100 to the left side. So how would Ingram finance this 100? Well, to be scale enhancing, it must be funded 40% debt, 60% equity. So Ingram must fund this with 60 in equity and 40 in debt for a total of 100, correct? That's what we call scale enhancing. And I think your authors make the comment that or they asked the question, do companies follow this mechanical way of funding? And the answer, of course, is no, they don't. Excuse me. So, but for 7.94% to be the correct WACC, this is what you had to do. 40% debt, 60%, okay. Companies do not generally follow their target capital structure on an investment by investment basis, but do so in the long run. So overall, they strive to maintain their target capital structure. Excuse me, but not on a project by project basis. Overall, they do. Okay. The WACC is only approximately correct if the company does not maintain a constant debt to value ratio. So what happens if they're not funding 40, 60? What do you have to do? There's actually two things you can do, but we're going to go through one of them right now. Right, and let's say that, now what's approximate? That's always a good question. But let's make the assumption that 15% is not approximately 40. So that's far enough apart that we can't accept that 794 would be the right cost of capital. Right? In two separate places in your text, your authors recommend a 3-step process for adjusting this cost of capital. Right? Now, the original 794 WACC is too far off to be called approximate. Borrowing less leads to less financial risk for the shareholders. More interest reduces the cash flows to be paid basically before the shareholders are paid. Okay, lower financial risk leads to lower cost of equity capital. So with 40% debt, what were the shareholders requiring? The shareholders were requiring, where'd it go? Here it is, 10.6%. That was based on 40% debt. Okay, what we're arguing here is that this number should be lower if we are using less debt. Does that make sense? All right, so let's see what happens. All right. Did all this. Okay. So you have two types of risk on the income statement. One is operating risk. You choose your assets, you now have your operating risk. Nothing you can do about it after you've made those choices. Financial risk is on top of that. That comes from using debt financing. So if you don't use debt financing, you have no financial risk. Right? So let's follow this. All right, so we're going to reduce financial risk. Okay, your author suggests that the easiest, now two words that don't belong in finance books. One would be easy, the other would be simple, and you see them both all the time. Excuse me, I guess if I wrote the book, I can call anything in it simple, can't I? But for everyone else, it isn't. To adjust the WACC for lower or higher financial risk, they say to follow this 3-step procedure, right? Okay, calculate the cost of capital. Oh no, look at that. I had an editor to go through this for me too. With, want to change that? Oh, Wilf, that's even better. Sounds like a Bible. With all equity financing. How did I miss that? All right. What would be the right cost of capital if the company did not use debt at all? What would the shareholders require from the company? Okay, all equity financing eliminates the financial risk. The cost of capital of all equity financing is the required rate of return, basically on the company's assets. Your authors refer to this rate as RA. Okay, we will use RA, and I got another term, RU we'll use also, but I'll explain that in a minute. So here's the equation that they offer us. Does this look somewhat similar to something we've already done? Very much so. It's exactly the WACC, but without the 1 minus T. So basically, what are you doing? You're removing the tax deductibility of interest, aren't you? And you think about this. If you're financing all equity, can you deduct any of those financing costs? No, you can't. So this is what it's doing. All right, so I take debt to value. So it's currently for Ingram, it's at 40%. I take their cost of debt. I add to that, they're currently at 60% equity, which corresponds to a 10.6% cost of equity. Okay. And then I arrive at 8.36%. So step one, what would be the appropriate cost of capital with all equity financing? We have it right here. Step two, now from the no debt financing platform, we're going to adjust it for 15% equity or debt financing. Okay, so since Ingram is financing the project with 15% debt, shareholders will require a higher rate of return when compared to financing with 100% equity, won't they? Because this is what they would require if we didn't use any debt. So with 15% debt, they will require a higher rate of return because more of the operating income will be paid out as interest, won't it? Without the interest, it would have flowed to the shareholders, wouldn't it? Okay. So the equation for adjusting the cost of equity capital starts with the cost of all equity financing and adds to it to reflect the added risk of debt financing. So here we go. RE, cost of equity, is equal to unlevered. So you can see what happens here. How does debt change this equation? It can only add to it, right? The second term, there's only one way to eliminate the second term. That's to do what? Have D equals 0, right? If D is 0, the second term doesn't exist, and therefore RE and RA are the same, aren't they? Okay, so let's just go through it, fill it in. 836, no debt, plus we're going to add to that 836 minus so in other words, RA minus RD, and then we'll adjust that for what are the debt to equity proportions. So if we will have 15% debt, two sources of permanent capital, it's either debt or it's equity. So it's 15% divided by 1 minus 15%, or 85%. All right, so now, do you see what the shareholders did? What's the big change for the shareholders for 15% financing? They've reduced their required rate of return from 10.6 down to 8.95. Ever see that? So that's going from 40% debt down to 15% debt. So they've reduced the cost of equity from 10.6 down to 8.95. See that? And let's keep going down the ladder. What happens if it goes to no debt financing? Then what do they want? Well, then they're going to require 8.36, aren't they? Right? So 836, no debt. 895, 15% debt. 10.6, 40% debt. You see that'll just keep going up, wouldn't it? We kept adding more and more debt. This will start to go up. All right, finally, let's go back and redo the WACC using the new information that we've just generated. Uh-oh, we lose power?
No, I haven't quite got one.
Oh, that's fine. Do whatever you got to do.
Yeah.
All right. Okay, so our new ratio, debt to value, will be 15%. Now, I didn't change the cost of debt, but you could make an argument that the cost of debt would come down if you borrow less. Okay, but we're going to keep it the same for simplicity here. Times 1 minus T times the new equity to value times the new cost of equity. So now we're down to 8.2%. So our new cost of capital is 8.2%. Okay. So notice, let's summarize what we did. Step 1, you use the current weights and costs of debt and equity. The equation for RA is identical to the WACC, except it does not have the 1 minus t term. And finally, steps 2 and 3 use values that are correct for the change in the financing proportions. All right, here's something we have to know. The concept of a beta. I'm sure you're like me, if you need a beta, you look it up online, right? Okay, but there's more than equity betas, okay? What is a beta? It's a ratio of risk premiums. What's a risk premium? Premium means in addition to. So there's some base in addition to that base. The one that we are most familiar with is the market risk premium. And what's that? That's the premium the average stock should earn above the risk-free rate. So that compares the return on the market to the risk-free rate. Okay, so the difference between the expected return on the overall market less the risk-free rate. That's the market risk premium. The betas that we will explore have in common the market risk premium in the denominator. So there's a ratio, risk premium divided by risk premium. Let's go through these. Hold on to your reins. We're going to jump into Excel pretty quickly here. All right. So equity beta, this is the one we see in all of our classes. It's the return on equity minus the risk-free. So that's one risk premium. That's the risk premium on the equity divided by the risk premium on the market. Now we can construct this for any value. Give me the required return on any type of securities minus the risk-free divided by RM minus RF. You have its beta, don't you? Okay. So let's come down here. How about your debt? One of the early assumptions that people did at one time was to assume that all debt was risk-free to keep things simple. Debt is not risk-free. So debt does has a non-zero beta. And so if we take the cost of debt, subtract the risk-free, here we go. That's the numerator risk premium. And one more time, the denominator will be the risk-free, the market risk premium. How about the beta of the assets? Okay, we take the return on the assets, subtract the risk-free, that's the premium in the numerator, divided by RM minus RF, premium in the denominator, okay? Now, one other thing worth noting here, we have this equation for RA. We just did that. So debt to value, RD, equity to value, RE. If you substitute, every place you see a R, substitute a B or a beta. So the beta of the assets is the debt to value ratio times the beta of the debt plus the equity to value ratio times the beta of the equity. Does that make sense, I hope? All right. So let's put all this together, and we're going to introduce the concept of rebalancing. And I just took this, I don't have better words than your authors do, except I would not have this one. But anyway, the formulas for unlevering and relevering expected returns are simple, but we must be careful to remember the underlying assumptions. The most important point being rebalancing. So rather than describing that, we are going to rebalance. See how to do it, what it means. Calculating the WACC for a company at its existing capital structure requires that the capital structure not change. And we could add on to that a bit. For the WACC to be the correct discount rate, you can't change your capital structure. Okay, I'll show you what that means. Let's go to the next page. I should have a nice example here. All right, and what I'd like you to do, of course, is just follow what I've been doing mostly this semester. Let's copy this table, and let's drop it into an Excel file. And let's put it just so we're all in the same, cell location. Let's insert this into the upper left-hand corner. Okay, I like my source findings formatted better. Okay, and I'm going to blow this up so we can see it. want you to, what do you think, well, here? Why did that work? Huh, I don't know. Anyway, okay. Now, there's something I have on the Word document that I would have you doing it later, but I think, now that I thought about it, we're better off doing it right away, and we're going to do that. And that is, we are going to enable ourselves to write equations algebraically rather than by pointing to different cells. Okay? Okay, this is how you do it. Let me show you. So I want you to do is highlight these first two columns and go all the way down. Let's stop at WACC. Okay, can we do that? We'll highlight those. Okay, then in your formulas menu, there's something here that says create from selection. All right, and what I did is I right mouse this and added it to my toolbar, so it's right here. I do this so often that I have it handy. But all you have to do, so let's just click on this for now. Okay, and it says create names from values in the and left column is correct. That's exactly what we want to do. So I'm going to say, okay. Let's see, how are we doing in Neverland here? You get that? Let's get our contrast thing going. Let's do this one. Okay. All right, any questions? Doesn't look like it. Okay, let's continue. All right, let's see if it worked. So I'm going to pick a random cell here, any old cell, and I'm going to say equals RD. You don't need to worry about caps. It should be blue, and when you hit enter, it should say 8%. See that? So every time I want to use RD, I don't have to go up and point to the cell, I just type out RD. So what this enables us to do is to enter the exact equations we have from the Word document. All right? So let's do it. All right, we just did the beta of the debt, correct? Just did that. Now let's do it again. So equals the risk premium on the debt. All right, and how do we do that? We'll take the RD minus what? How do we get a premium? Over and above the risk-free. Okay, and every one of these betas divided by, it's a ratio of risk premiums. So what's the risk premium in the denominator? It will always be the market risk premium. Okay, so we're going to say RM minus RF. See that? Excel very nicely highlights all the cells for you. And so we should get a beta of 0.6667. So 666, the mark of the beast. This must be an evil, evil, evil debt. You ever know if that's not actually right? The Caligari? I can't think of the name of the emperor, but anyway, he was the beast, and his mark is not spelled with Roman numerals that make 666. It's actually wrong. So that's been a bad rumor all these years. Who knows? Anyway, I don't know what. Let's keep going. Unlevered beta. Okay. Exact same procedure. We're going to see what the ratio of the premium above the risk-free for the unlevered rate, RU. What is going on here? Why are they cutting me off on these? I don't know. Oh, they're centered. No? I know that won't work. I've never seen this happen before. Okay, anyway, we have a premium for the unlevered cost of capital, the no debt cost of capital. So here, you want to make a note over here? This is the no debt cost of capital. So if you have no debt, this company's cost of capital will be 12%. Right? And so let's see what kind of premium that represents. So it equals, it's an 8% premium, right? 12 minus 4, I can see that from here. So we're going to take RU, subtract risk-free, and that compares to the market risk premium. So go ahead and do it. Compare that to the market risk premium. I get 133. Is that a good number? Okay. All right. So that's the unlevered beta. All right, let's do the levered beta. And we're going to use an equation that looks like this. We're going to say beta levered equals beta unlevered plus then a premium. Beta unlevered minus the beta of the debt times the debt to equity ratio. Okay? So let's try it. We're going to say equals beta unlevered plus beta U, beta unlevered, minus beta of the debt times, okay, in this case, we want debt to equity, we're just going to use the leverage ratio. That's the L up here. L means leverage, debt to value ratio. So if debt is 30% of value, then that means equity must be 70, right? Or 1 minus that. So here's what we'll do. Times the L. I'll capitalize so it looks the same. Oh, look at that. I uncapped it. L divided by, so I want debt to equity. So if debt is 30%, equity must be 1 minus 30 or 1 minus L. Okay, there we go. Again, these name ranges are indifferent to caps or small upper or lowercase, doesn't matter. Okay, so let's see what we get. We get 1.1619. All right, I'll put you in charge of the next step. If I give you a beta of 1.169, a risk-free rate of 4%, return the market of 10%, what's the required rate of return on a stock with a beta of 1.619? Go ahead. Should take you 10 seconds. I'll give you more though. All right, I'll do it. So, capital pricing model, capital asset pricing model equals risk-free. Oh, let's not cap that one. Risk-free plus the market risk premium times the levered beta. How do I know whether to use the levered beta or the unlevered beta? Well, if a company uses debt, you have to use the levered beta, don't you? If the company doesn't use debt, you could just use the beta of the company is an unlevered beta. Okay, and I show for this 1.169. or I'm sorry, 13.6. Now, you know what we should do with these? Let's get this one here, since it's a return. Let's do that in percent with 2 decimals. Okay, how else can we do this? We can do this another way. Let's get the exact same answer. Okay, and that would be, remember how we just did this beta right here? Just did this beta right here. Oh, we did this beta right here. Okay, if we substitute r's for every place we see a b, we'll get the required rate of return. Okay, let's do that. Equals, instead of bu, we're going to say ru. Plus, instead of bu minus bd, we're going to say ru minus rd. And in the end, that's the same. So debt to equity, so times the leverage ratio, divided by, so debt to equity, 1 minus the leverage ratio. You ready? Drum roll. Oh, look at that. 13.71%. With just a tad of algebra, you could show that these have to be the same, but we're not going to spend time with that. All right, your turn. Tell me what the WACC is so we get going on this project. What's the WACC? Go ahead. You got the equation just to the right there. Should take you about 15 seconds. All right, I will do it. Equals leverage times RD times 1 minus the tax rate plus 1 minus the leverage ratio times RE. Third. So again, percentage, 2 decimals. Okay, let's check in. Recording is started. All right. All right, seeing no objections, I'm going to continue. All right, so below we have a project with a cost of 300, with expected cash flows of 100, 200, 300. Okay, so this value, this capital B, is the value of the project. Okay, notice what words are missing, or what words are missing here compared to what we've done in the past. This is value, not net present value. This is just value, right? How do you value any asset that there is? It's the present value of all future expected cash flows discounted at a rate appropriate for the risk, right? So how do we value this project? We are going to discount these 3 cash flows. That is, how do we value it in year 0? Well, you have 3 expected cash flows, don't you? So we are going to discount those back at the WACC. So go ahead and do it. Oh, I actually don't. Follow me. One little thing will make this easier if you do it right. I mean, what I told you is very much correct. So I'm going to say equals NPV. Okay. And then if we've named our ranges correctly, we can say WACC. Looks like it's spotted at 11.5 for us. Okay, now here's where a little bit of difference. Okay, there'd be absolutely nothing wrong with just going like that, and I would have the correct number. But I want to copy this. Because what happens next year? At the end of year one, how many expected cash flows do you have? You have cash flow 2, cash flow 3. How many expected cash flows do you have at the end of year 2? You have 1. How many cash flows do you have at the end of year 3? None. Okay, so let's make this equation work for all circumstances. What I'm going to do then is I'm going to highlight one cell below. See that? And then I'm going to lock just the second number in the range. So in my case, it's the B19. I'm going to lock just that B19. So do you see what happens? Each time I copy this cell down, what does it do? It stops right here, doesn't it? And then for the last one, it'll just look at this blank cell and say 0, won't it? Okay, so we got that. And I get 467.02. All right, so let's get a benchmark for everything else we're going to do today. Okay, let's get a benchmark. And that would be over here. If I were calculating the old-fashioned, what we've done forever, NPV, what would I get? Go ahead and do it. It should take you 5 seconds. I'll bid 2 seconds. I'll bid 1 second. Can someone do it instantaneously? All right. Okay, this is the present value of cash flows 1 through 3. This is cash flow 0. Add them together, right? So I just come here and I do auto sum, and I highlight these two. Oh, it's a very positive NPV, isn't it? So we would accept this project, wouldn't we? Okay, now we are going to value it using 2 other methods. All right, and we need a number of other numbers in order to complete those measures. So let's start out. Okay, you're the corporate treasurer. You're my corporate treasurer, and I propose to you to fund a project that has 3 cash flows, 100, 200, 300 over the next 3 years. How much can we borrow against that project? How much? How much can I borrow? I don't know if you got the gist of what we've been doing, but what do you think this leverage ratio is? Debt to value, market value. Okay. This 46702, is that a market value? Yes, it is. So you can borrow, to keep your capital structure correct, you can borrow 30% of that. So let's do it. Equals L times okay. So there's the debt. So what's the market value of the equity? So if this is 46702, 140.10 is the debt. What's the equity worth? Well, it'd be the difference, wouldn't it? This one minus this one. So 326.91 is what I get. All right, let me show you something. Let's go back to the Word document for just a moment. Because we're kind of trucking along here, whether you know it or not. Let me just keep going. Okay, right here. So this is the Sunshine Company. And this is what they've done to their balance sheet. The market value balance sheet. They've added 46202, 46702 to the left side. They've added 140.1 and 326.91 to the right. Okay, so this is what they've added to their market value balance sheet. What happens next year? Well, next year you have one less cash flow. So this project loses value. It will be worth 420, and we'll see that. And you can see that this debt will go from 140.10 down to 126. So we have to reduce the debt by that difference. That's called rebalancing. Okay, let's do it. It's easier to do than it is to describe. Let's go back to Excel. Okay. Now, with a little bit of luck, I hope we get through this. If we've followed my instructions, and if I follow my own instructions, I can click on the lower right-hand corner of this range and just double click it. It should fill in the next 3 years. All 3 years. Look good? Got it? Perfect. Let's check out Neverland. That didn't. Okay. All right. Let's keep going. Okay, so far. Thank you, thank you, thank you, thank you. All right, let's get this. Keep going then. All right, so at the end of the first year, we have to have the debt to keep it 30% of value must be reduced to 126.21. We started the year to equal 0 with 140.1, so our change in debt will be that difference, won't it? That would equal 140 minus the 126.21. All right, and how much interest will we pay the first year? The way to do this is to view the debt as a series of 3 different loans. Okay, so how much did we borrow immediately? We borrowed 140.1, and that's at what? 8%, correct? So let's pay interest on it. Equals 140.1 times 8%. You didn't do that, did you? Thank you. Times RD, right? What's nice about this RD? You want to set this up for a different problem? What do you do? Just change the numbers on top, change the cash flows. It goes boink. It's done. So don't type in numbers. Never type. Never, never, never. Okay, here we go. All right, RD. Here we go. Interest. We got it. Okay. Now, interest you always pay on an after-tax basis. Okay, and the amount by which you can reduce the interest to make it after tax is the tax rate times the interest. So if I just multiply this, it's called the tax shield, interest tax shield. So because you have this interest expense, you'll pay some amount of taxes less. And so it's equal to T, tax rate, times the amount of interest. So it'll be 235. Good number? Okay, I'm going to swing back to the, what do we got here? Oh, nothing, okay. I wonder why it's changing colors on me. Who knows? All right, let's swing back to the Word doc.
Good question. Could you
Yeah.
show the equation one more time for the INT column?
The interest?
The interest column?
Is that the one?
Yes.
Do
Thank you.
You understand the principle of it?
Yeah.
You borrowed 140.10 for 1 year at 8%. And that's what RD is, right?
Perfect. Thank you.
Yeah, I didn't mean to set you behind by typing in the 8%. That was probably could have done without that. But that's what we did in effect. Okay, are we okay on the tax shield? So just T or 21% times 11.21. Okay. All right, now I'm going to swing back to the Word document. All right, and let me see where, here it is. Okay, so I have a balance sheet here. Let me show you how they work, or a balance sheet, I sure do. An income statement. So you start out with your revenues, you deduct your cost of goods sold if you're a manufacturer, your selling administration, your depreciation, then you get what's called operating income, EBIT. All right? What comes out next? Interest, correct? What comes out next? Well, interest is tax deductible, so we will deduct the interest from our EBIT before we pay taxes. Then we'll pay taxes. And then, before we can distribute any of this EBIT, what remains of it, to the shareholders, we have to pay back any principal payments on money that we've borrowed. We have to pay back, or not pay back, but pay out our preferred stock dividends if we're using preferred stock financing. Sunshine is not using that, so that's not an issue with us. And finally, the rest is available to common. Okay, so a mental image. Where do shareholders come into an income statement? Well, I look at it this way. If the income statement above were a lake, the shareholders would be bottom feeders, such as the carp. That's why I put a carp down here. That's your shareholders. They're down here. They're at the bottom. Everybody else gets paid first, don't they? And think about it. If you go into liquidation, that's the same story, isn't it? Everybody else first. You're last. Last. That's why shareholders require higher rates of return than the other capital providers. All right. So let's apply this logic to estimate how much of this $100 will reach. Okay, let's come up here. Let's give this thing a definition. This is called flow to equity, FTE. Okay, FTE is the flow to equity. So how much of this $100 reaches the shareholders? Let's start. Equals 100. Okay, now we're going to start coming down the income statement. Okay, and what was in there? Well, you had any debt you had to repay. Oh, how did I do that? Let's start again. Got that one? Minus any debt that you had to repay. Okay, minus interest. Okay, but you pay interest on an after-tax basis. So we'll reduce the amount of interest you pay by the interest tax shield. So I'm going to put a plus on that. And so I see of that $100, the shareholder sees 77.25. Do we get that? Okay, what'll I do next? I'll do the next 2 years, and that'll take me how long? About 3 seconds, right? If I'm really in a lazy mood. Okay, so we'll take these, and we'll double click right over here. And we have the, what happened here? Oh, okay, I can buy that. All right, so what does that tell me? Second year, 200 after-tax cash flow, the shareholder sees 146. 300, 214 to the shareholder. All right, and so up here, we already know the NPV is 167.02, do we not? We've done that. Okay, there's another method. And this other method, and we can summarize, let's go over here and maybe write that out. This is called the adjusted present value. And this is the main method that's of focus in Chapter 19. So it's an alternative to the NPV. All right, and let's go to the bottom here, and you can see that the APV is equal to the NPV discounted at the unlevered cost plus the present value of the tax shields, and in this case, also discounted at the cost of unlevered equity. Okay, so this first term is called the base case NPV. So what happens when we did the NPV, what did we do? We discount all the cash flows at one rate. And that rate was blended between debt and equity, correct? Okay, what you do with this APV is that you split the cash flows. Okay, you take the unlevered cash flows and then you take the tax shields. So let's do that. Let's start out over here and let's just go up a little bit and just restate the cash flows. All right, and then let's get the interest tax shields. We have these over here. You don't have to do this, but it's nice to summarize all this. All right. Now, just a little hint of things to come. The WACC requires that we rebalance every year, and in this problem, to maintain a constant 30% debt to value ratio at market values, correct? We've done that, haven't we? Isn't that what all this rebalancing was, paying back this debt, correct? All right. That is not a requirement of APV. APV does not require rebalancing, but it works if a company does rebalance, but that's not a requirement. All right, so we're going to work for now on the case where the company does rebalance. All right, and so let's start out with the NPV. First of all, what would the NPV be? That's this first term here. If we valued the project using the unlevered cost of equity as the cost of capital. So I'm going to say equals NPV. And then rather than using the WACC, I'm going to use RU. So 100%, you know what, I don't like that. Let's start over. NPV, RU, and then your cash flows, 100, 200, 300. And then subtract your initial cost, that's the minus 300. And I get for this 162.26. So question for you. If, rather than using 15% debt, the Sunshine Company decides to go no debt, would they still accept this project? Why do you think yes?
It's positive.
Perfect. What's positive? NPV, absolutely. Don't change your ways in life. You know, positive NPVs or positive NPVs. The answer is for sure. This is a positive NPV. We would accept it if it were financed at a cost of capital of RU. Absolutely. Now the tax shields. Okay, we got a little bit of time here. Let me show you something about the tax shields. All right, I think I've mentioned this in the Word document. Let's go back up to our cash flows. Okay, do we see that, how did we get this value? This value is the present value of these three cash flows, isn't it? So once I had the value, how did I get the debt? It was a constant number times the value, wasn't it? In our case, 30%, right? How did I get the interest? The interest is a constant times the debt, isn't it? The interest rate. How did I get the interest tax shield? It's another constant, 21% times the interest. So can you see there is a direct link between these cash flows and these interest tax shields? Am I right? So in other words, what if I, for example, what if I changed, let's change this first one to 50. We'll change it back if we have to. But just to see what, now watch what happens to your interest tax shield. Oops, I'm pushing the wrong key. See that? It changes. It has to. Okay, so can you see that those interest tax shields are tracking the cash flows, aren't they? Interest tax shields are tracking the cash flows. Okay, let's go back to where we were. Let's not keep a bad number in there because we got another method to do still. Okay, the interest tax shields are tracking the cash flows. Okay, so would it be reasonable then that this stream of cash flows is equally risky to this stream? Yes. So this stream of cash flows and this stream of cash flows are equally risky. If we rebalance every year to maintain a constant debt to value ratio, these are directly tied to these. So if these and these have the same risk, or sorry, these and these have the same risk, it would make sense to use the same discount rate. And that's just what we'll do. Okay, so the present value of the tax shields equals NPV. And you can see right down below there, it says present value tax shields R equals RU. So we'll use RU. And then we'll, so what have we done? We have the value of the project if it's 100% equity financing, plus any additional benefits of debt financing. So we split it up into two parts. Okay, we get that? And if I add these together, where have we seen that before? 167.02. So under the same assumptions, the NPV and the APV should result in exactly the same number. I found it interesting years ago, back when we had real classes and I gave paper exams, I would ask a question such as this. People have to calculate all this. And then I would put a little thing at the bottom saying, does your APV and are your NPV and APV equal? And of course, some people did it incorrectly and got it wrong. And they said, no, it's not. And my next question was, if it's not, why? And people would write 3 or 4 paragraphs telling me why the NPV and APV weren't the same. And I'd actually give them back 1 point if someone wrote on there, I made an error. They have to be the same. Under the same assumptions, they are the same. So you can even show this algebraically, and we certainly aren't going to do it, that these absolutely have to be the same under the assumption of rebalancing. Now, if you don't rebalance, if you do not maintain a constant debt to value ratio, then they're not going to be the same. And we'll get into that in our next class period. So I think I'm just going to stop here, leave remaining time we might have to tie up any loose ends, which we might have. So if everything has been okay, I will see you in a couple days. Otherwise, if you have a question, you'd like to correct something on your worksheet, go right ahead and ask me. And I'll click out to Neverland here, see if we got any last minute questions. Oh, could you show the formula for PV of the tax shield? Oh, I sure can. I will do.